Hey, lesson 20 is about triangles, three-sided polygons. Probably the biggest thing to understand with triangles. You can classify them by angle size or classify them by side length. And they're going to start by doing angle size, and then they're going to move on to side length. So when we're talking about classifying triangles by angle, you look for the largest angle, like in this first one. Maybe it's this one right here. And then you determine, is it less than 90 degrees? Is it more than 90 degrees, or is it 90 degrees, right? So less than 90 is acute. The largest angle being acute means it's an acute triangle according to its angles. Biggest angle is obtuse, is more than 90 degrees, so obtuse triangle. You can't have two angles that are obtuse, so all you need is one when you're making a triangle to make it an obtuse triangle. And then this box, remember what measure is that implying? That is a 90-degree angle. A right angle, as you might call it. So it's a right triangle. That's its biggest length. Angle size, I should say. Remember, all angles, though, add them up, 90 plus 45 plus 45, or whatever it may be. All three angles of a triangle will add up to 180 degrees, no matter which triangle. All three of these would do that. How about side length? Three new ways to talk about triangles are equilateral, isosceles, or scalene. This is when we're classifying by side lengths. Got it? So you could have an equilateral triangle that you could also call an acute triangle. It's the same type of triangle, right? Because look at the biggest angles are always 60 degrees on these guys. Something else to note, that equilateral means all sides are the same, and when all sides are the same, a truth of geometry with triangles is that all angles will also be the same. So that's the equilateral triangle. Isosceles means it has at least two equal length sides and at least two equal angles. So we use these tick marks when there's the same number on each side to show that this side and this side have equal lengths, making it an isosceles triangle. Scalene is the misfit of the bunch. None of these sides are the same. You could use tick marks to show that if you wished. So it's a scalene triangle, meaning none of the angles would also be the same. Still with me? Let's classify this triangle. Notice how they label it, A, B, C, in the order, one way or another. You can't go well, there really is no way to go out of order with a triangle label, I suppose. But anyway, they call it ABC, you could call it triangle BAC, whatever. Classify it by angles first. Okay, I see this right angle, that's my dead giveaway, it's a right triangle. Then we also want to classify it by sides. And if you were to measure this, you would see that the sides are all different lengths. It's just clear looking at this one and this one that they are not the same length. And this side, just a good thing to remember, this is called the hypotenuse. It'll always be longer. So it definitely can't be the same even as the bottom one. The roof of a building in the drawing slopes at 35 degrees. What's the measure of the angle at the peak of the roof? Remember, the total of all the measures is 180 degrees. So if we have a 35 and a 35, how could we find the remaining angle? This top angle. Add your known angles, which is 70 degrees, right? That's these two. The last one should give us 180 in total, according to the rules of triangles. So, missing number problem, what is this? They say it's 110, right? Sorry, that might happen a little bit on these videos. I'm having issues with the drawing pad a little bit. Now let's just quick talk about area of a triangle, right? Perimeter is the same, it's the distance around it. So if you ever have to find the perimeter of a triangle, you need to know the side lengths, add all three up. But with an area, we've always learned, well, what's the formula of an area of a triangle? It's the base times the height, which is this, not this, because this is just a slant, right? Height means what's the distance from the base to the peak. So even though this line isn't technically part of the triangle, it's showing us the height. And then we always had to divide that by 2 to find area of a triangle. Do you know why that is? Because if we just did bottom times top, which you could also think of it as length times width, What we're really doing is finding the area of the entire rectangle around it. So if you were to find, base times height, what would you be finding? You'd be finding all of this. And the triangle is about what fraction of all of that? Well, if you added the z portion and the y portion together with the they would equal the w and the x portion. Z times y, z plus y is w plus x. So that extra part is the other half. Okay? If you find the whole rectangle, you're finding twice as much as the triangle. So we use base and height, remembering that in a triangle like letter B, 6 is the height. It's not in the triangle, but it is showing the distance from the base to the peak. Okay? So I know this is here, but this is called the slant height, and we do not use it. We use this imaginary dotted line. We don't use this for the base, in case that's something you're worried about doing. That would not be it. You just use 6, just the actual base. And you don't use the hypotenuse for area at all, which is the slant. Use what's sitting on the ground. So over here, this one's turned, but that's the base right there, right? You need to turn that guy around so that we're looking at 8 times what? What's the height on this one? Base is 8. Sorry, I don't know what the deal is. Base is 8 times 7. And then you got to divide by 2 to find the area of a triangle. So 56 divided by 2. See if we got that right. Let's scroll down. You can also think of it as 1/2 the base times the height. That's the same as saying base times height divided by 2. Here's our letter C. The base does not need to be horizontal and the height vertical. The base is 8, height is 7. Turn the book if you needed to see that better than me just going like that. Right, you could turn your book. So they did 1/2 8 times 7, or 1/2 56, and that comes to 28. Okay, classify the triangles. Try letter D, and then let's do through G. So let's do A through G, please. They're pretty quick. Good luck.